the grade 12s, welcome back to it. It's Maths Masterclass with Leo. Welcome to our session of winter classes. Today we are doing, our main focus today is on sigma, but we need to start with the sum of the series, which we did not do sum of the series of sum of infinity, right? We did not do sum of infinity, hence we start here. In the previous video we did sum of the series. We did introduce some of the series for linear or arithmetic, and we did introduce some of the series for geometric. So today our focus area is on geometric, specifically the questions that are related to sum of infinity, right? So let's do this question, which is 3 plus 1 plus 1 over 3 plus 1 over 9, da da da. Okay, now this question, it says determine the value of n, the value of n for which the sum of the first n terms is 1 to 1 over 27, right? So this is just a bit of revision because we did this in our previous video. We did this, so this is just a revision before we get into sum of infinity. So in this case, if we analyze this question or the statement, we can take out our data, which is Sn is 1 to 1 over 27, right? We can calculate the value of r since we have the series. The value of a is represented by 3, right? So we're looking for the value of n. We can calculate the value of r. So r is equals to t2 over t1, which is 1 over 3 in this case, and r is t3 over t2, which is 1 over 3 divided by 1, which is 1 over 3, right? And then r is 1 over 3, and it is what I'm looking for. I don't know it, right? So in this case, I know the formula. It says Sn is equals to a into r to the power n minus 1 close bracket divided by r minus 1. And then I know what is Sn, which is 1 to 1 over 27. This is equals to a is represented by 3 into 1 over 3 into 1 over 3 to the power n minus 1 close bracket divide by r, which is 1 over 3 minus 1. Then 1 to 1 over 27 is equals to 3 into 1 over 3 to the power n minus 1 close bracket. Then when I say 1 over 3 minus 1, this gives me negative 2 over 3. Then I can cross multiply, which will mean 1 to 1 over 27 will multiply negative 2 over 3. This gives us 3 into 1 over 3 to the power n minus 1, right? And then if I multiply 1 to 1 over 27, multiply negative 3 over 2, negative 2 over 3, it gives me negative 242 over 81. This is 3 into 1 over 3 to the power n minus 1. Then divide by 3, divide by 3. Then this gives me, divide this by 3, it's negative 242 over 243. This is equals to 1 over 3 in bracket to the power n minus 1. Let me just remove the bracket so that I can transpose. Then this gives me negative 242 over 243 plus 1. This is equals to 1 over 3 to the power n. Add 1 to this solution. It is giving me 1 over 243 is equals to 1 over 3 to the power n. Then change this to exponentials. This is 1 over 3 to the power what? Let's see. 243 equals to shift factors. This gives me 3 to the power 5 is equals to 1 over 3 to the power n. I can change this to 3 to the power minus 5 is equal to 3 to the power minus 1 in bracket n. Right? Go to the next page. Then I still have my 3 to the power negative 5 is 3. According to the laws of exponents, this will be 3 to the power negative n. Bases are the same, leave them out. Deal with the exponents, negative n. Then if I divide by negative 1, divide negative 1, I can therefore see that n will be 5. Right? My value of n is equals to 5. Then I'm done with that question. The second question, determine the sum of infinity. Determine the sum of infinity. The sum of infinity. Right? Sum of infinity, the formula that we can use is this. But we can use it only on one condition, when the value of r is in between negative 1 and 1. But we already know what is the value of r, which is 1 over 3, which is 0,3333 recurring, right? So in this case, I can therefore use this because I can see that r is in between negative 1 and 1. Then I can say the value of a, if I remember very well, it was 3 divided by 1 minus into 1 over 3. Then if I punch my calculator, 3 divided by 1 minus 1 over 3, it gives me 9 over 2. That is how I can calculate the sum of infinity. That is how I can calculate the sum of infinity. Let's get another question with the sum of infinity. Say we have, they say, determine the sum of infinity. Determine sum of infinity. Infinity for this series. Right? The series is given as 5 minus 2.5 plus 1.25 minus 0.625. Right? From this, I can now calculate the value of r. R is equals to T2 over T1. R is equals to T3 over T2. Right? So this is negative 2.5 over 5. So if I say negative 2.5 divided by 5, I'm getting negative half, negative 0.5 or negative 1 over 2. Then if I say T3 is 1.25 divided by negative 2.5, so negative 1.25 divided negative 2.5. So this also gives me negative 0.5. So now I can see that this r is in between negative 1 and 1. Therefore, I can use sum of infinity is equal to a over 1 minus r. Then it means this will be 5 divided by 1 minus into negative 0.5. Let's see my solution. 5 divided by 1 minus into minus 0.5. I'm getting 10 over 3. That is my solution for this question. Let's move. That is what I wanted to show you when it comes to some of the series. Now, we're moving to sigma. They say sum of tk is equal to your Sn. This is very, very important. Don't forget this. Sum of tk is equal to your Sn is very much important without any further complaints. So the main important thing is to be able to rewrite your series and write it in terms of sigma notation, and again be able to write your sigma notation in terms of a series. So let's see. The first thing is to rewrite this question in terms of sigma notation. By given this series, we need to write it in terms of sigma notation, right? This is 39 at the end plus 39. So we need to write this series in terms of sigma. So sigma Here, which is represented by n, this is the position of the last term, position of the last term, right? The position of the last term will come here. Here, you'll have your nth term, general term, formula, right? You can call it your nth term, your general term, or your formula. That is where you'll get your formula. And here, underneath, which is t is equals to, this number that is here represents position of the first term. First term, right? The position of the first term, it will not always be at 1. It changes, it varies, right, with questions. So in this case, so it means we need to calculate the formula. We need to know what is the position of the last term. We need to know what is the position of the first term, right? We need to know, how did they get this one? What is the position of this one, right? So in this case, definitely this, we can see that this, if I do this, 2, 2, 2, right? It is an arithmetic sequence. That is an arithmetic sequence. Arithmetic sequence, the formula for arithmetic sequence, or the nth term for arithmetic sequence, is Tn is equals to a plus into n minus 1 close bracket d, right? So a is represented by 1 plus into n minus 1 close bracket. D, it is your t2 subtract t1, then it will be 3 minus 1 is 2. D is t3 minus t2, which is 5 minus 3, this is 2 as well. D is represented by 2. Then I have 1 plus, if I multiply this 2 by n, it will be 2n. 2 by negative 1, it's negative 2. Then I have my solution as 2n minus 1. That is my nth term, the general term. Now I can do that and say my general term will be 2n minus 1. Some they say 2k, some they say other things is fine, right? It's up to you. Even if you say 2k here, 2k is a k, right? And then I want to know what is the position of the first term. Position of the first term, if I substitute 1 here, what am I going to get? 2 into 1 minus 1. I'm getting 1. Meaning the position of the first term is at 1. Right? The position of the last term, we need to calculate that. We need to know what is that. We know that this represents what? The actual number represents your Tn. Right? So in this case, 39 is equals to 2n minus 1. This to the other side, 39 plus 1 is equals to 2n. If I divide by 2, divide by 2, therefore n is equals to 20. Therefore here I'm going to have my 20. That is my sigma notation. I've represented my series in a sigma notation. Let's go to the next page. Next page, I want us to check the sigma notation for geometric series. 2 plus 6 plus 18 plus 54 plus 1, 3, 1, 2, 2, right? So in this case, we know for this, if I want to calculate for my sigma, I need an nth term here, the formula. I need the position of this term. What is the position of this term? I need the position of this term. What is the position of this term? So that's what I'm going to do. Now, sum this one. If this is a geometric series, R is equal to T2 over T1, right, which is 6 over 2, which is 3. And R is equal to T3 over T2, which is 18 over 6, which is equal to 3. And then the formula, or the nth term, Tn is equal to AR to the power n minus 1. And then A is represented by 2 into 3, which is my R, n minus 1. Meaning here I'll have 2 into 3 n minus 1. That is my formula, or my nth term. And then if I substitute 1 here, what will I get? If I substitute 1 here, what will I get? 2 into 3 to the power 1 minus 1. That gives me 2, meaning the position of the first term is 1, right? If you are using n, use n consistently. If you are using k, use k consistently, right? So in this case, k is equals to 1, meaning the position of the first term is at 1. Want to know the position of this term. So this, the actual number represents what? Your Tn. Don't forget that. So it means here I can say 1, 3, 1, 2, 2 is equals to 2 into 3 to the power n minus 1. Then if I divide by 2, divide by 2, this and that, they cancel. Then 1, 3, 1, 2, 2, divide by 2, it's 6, 5, 6, 1. This is equals to 3 to the power n minus 1. And then I can change this to exponential factors, which gives me 3 to the power 8. This is equals to 3 to the power n minus 1. According to laws of exponents, bases are the same. I can leave them out, deal with exponents. This will be 8 is equals to 3, not 3. 8 is equals to n minus 1. And then 8 plus 1 is equals to n. Therefore, n or k is equals to what? 9. So in this case, the position of the last term is at 9. The position of the last term, it is at 9. That's how I can represent this in a sigma notation, right? Now let's do the reverse of it. For a given sigma notation, we're given 2k minus 7, we're given k at 4, we're given last term, the position of the last term is 13. If we're given something like this, the first thing is to write this in terms of a series, which will be 2k minus 7 is 2. You can say is 2, or you can say, because you are writing it in terms of a series, plus 2k minus 7 plus 2k minus 7 plus 2k minus 7, right? There's no need for you to write all of them from 4 to 13. Just 4 is fine. Just the first 4 is fine, or the first 3 is fine. So this will be 2. The first term, the first position is at 4. So this will be 4 minus 7 plus 2 into 5 minus 7 plus 2 into 6 minus 7 plus 2 into 7 minus 7. Meaning this will be 1 plus 3 plus 5 plus 7. That is what I have, right? That is what I have. Now, from here, from this, I can do what? I can see that this is my pattern, right? This is my pattern. Let's try to calculate value of Sn. What will be your Sn? So in this case, pattern is an arithmetic sequence. Arithmetic sequence, and then for arithmetic sequence, you need the value of A, which is 1 in this case. You need the value of n, which we will calculate because we have this and that. And then if we calculate them, we can say, now we start at 4, we end at 13. You can use your fingers to count 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You can see that n is equal to 10. N is equal to 10, right? The value of n is represented by 10. Or you can say this formula, n is equal to top minus bottom plus 1. Meaning this will be 13 minus 4 plus 1, which means this will be 13 minus 4 plus 1. 13 minus 4 plus 1 is 10. Right? That is the formula that you can use, or you can use your fingers to count. Right? This is the formula. Okay, and then after that, we have the value of n. We're looking for Sn. We can calculate the value of d. D is T2 minus T1 or T3 minus T2. Meaning here I have 3 minus 1, which is 2. Here I have 5 minus 3, which is 2. Right? Sn is equals to n over 2 into 2a plus into n minus 1 close bracket d. And then n is represented by 10 over 2 into 2. First term is 1 plus into 10 minus 1 close bracket 2. This gives me what? 10 over 2 into 2 into 1 plus into 10 minus 1 close bracket multiply by 2. This gives me 100. That gives me 100, right? Okay, the next question, it is a geometric one. Let's see, what do they want? So we're given sum of this is 7, k is equals to negative 2, then the nth term is 2 multiplied by 3 to the power k plus 1 plus 2 actually. Then they want to know what is your Sn. Calculate the value of Sn. The first thing again is to determine the series. 2 multiplied by 3 to the power k plus 2 plus 2 multiplied by 3 to the power k plus 2 plus 2 multiplied by 3 to the power k plus 2 plus 2 multiplied by k multiplied by 3 to the power k plus 2. So it's up to you. You can do at least 3, right? I always prefer doing 4. So in this case, I can say 2 multiplied by 3 to the power negative 2. It starts at negative 2 plus 2. Then plus 2 multiplied by 3 to the power negative 1 plus 2 plus 2 multiplied by 3 to the power k, which is 0 plus 2 plus 2 multiplied by 3 to the power 1 plus 2. Then here, this will be 2 plus 6 plus 9 times 2 is 18 plus 27 times 2, 54. Right? And then I can now calculate the value of r, which is T2 over T1, which is equals to 6 over 2, which is equals to 3. And then I can verify it. T3 over T2, this is 18 over 6, this is 3. Right? And then for geometric, I know Sn is equals to a into r to the power n minus 1, close bracket, divide by r minus 1. I know the value of r. I know the value of a. A is equals to 2. R is equals to 3. N. What is n? Now, n you can use the formula or you can count. When you count, you'll have negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7. This is 10, right? I counted 10 fingers. Or you can say n is equals to top minus bottom plus 1. That is a formula. It works everywhere. So top we have 7. Minus of minus 2 plus 1. This gives you 10. Then substitute. Sn is equals to 2 into 3 to the power 10 minus 1, close bracket, divide by 3 minus 1. Then what am I getting? 2 into 3 to the power 10 minus 1 divide by 3 minus 1. What is my solution? 59048. Right? That is how I can calculate it. Now, let's say we have unknowns. We need to calculate those unknown. That is our last part for the day. We want to calculate unknown. Okay. Let's say we're given the first question, which is an arithmetic one. X here, and then k is equals to 4. And then we have 2k minus 7. They are saying this is equals to 100. Remember, Sum of tk is equal to your Sn, meaning this is your Sn, right? Meaning that is your Sn. So we need to calculate what? The value of x. We need to know what is the value of x. But we can't get the value of x if we don't know the value of a, if we don't know the value of d. And how do we get that? We get that from a series. Let's do a series. 2k minus 7 plus 2k minus 7 plus 2k minus 7 plus 2k minus 7. So it starts at 4. 2 into 4 minus 7 plus 2 into 5 minus 7 plus 2 into 6 minus 7 plus 2 into 7 minus 7. This gives me 1 plus 3 plus 5 plus 7. Right? Then I know what is the value of a now. A is equal to 1. I need to know what is d. D is equal to t2 minus t1, which is equal to 3 minus 1, which is 2. D is t3 minus t2, which is 5 minus 3, which is equal to 2. Then d is represented by 2. Right? Now I need to know what is the value of n. I don't know what the value of n is, so I can calculate it. Sn is equal to n over 2 into 2a plus into n minus 1 close bracket, and then here I'm going to have my d. Sn 100 is equal to n over 2 into 2, value of a 1, plus into n minus 1 close bracket d. Then 100 multiplied by 2 is equal to n into 2 plus d we said is 2. D we said is 2. This will be 2n minus 2. This and that 0. Then 200 is equal to 2n squared divided by 2 divided by 2. 100 is equal to n squared, right? And then square root, n is plus minus 10. Therefore, n cannot be negative 10. Therefore, n is equal to 10. Right? N is equal to 10. But remember our formula. Our formula says n is equal to top minus bottom plus 1. And then top is x minus bottom is 4 plus 1. Then n is represented by 10. So we have 10 is equal to x minus 3. This to the other side, it will be 10 plus 3 is equal to my x. Therefore, x is equal to 13. And therefore, x is equal to 13, right? And then let's do our last question, which is we're given sum where we have x. This is k is negative 2, and then 2 multiplied by 3 to the power k plus 2. This is 59048, right? And then we need to calculate the value of x, right? But we can't calculate the value of x if we don't know the value of a, if we don't know the value of b. No, if you don't know the value of a, and if you don't know the value of r. I don't know where am I getting b, but yeah, a and r. So we're given Sn is equal to 59048. R, we don't know. And A, we don't know. N, we don't know. But these two we can calculate. After calculating these two, we can calculate N. Calculating N, we can use the formula N is equal to top minus bottom plus 1. Right? Where now top is x minus bottom is of minus 2 plus 1. Then this is what? This is x plus 3. Right? That is x plus 3. Then let's do that. Let's calculate r, a, and then calculate eventually the value of n. Right? Now, n. We have 2 multiplied by 3 to the power k plus 2 plus 2 multiplied by 3 to the power k plus 2 plus 2 multiplied by 3 to the power k plus 2 plus 2 multiplied by k, 3 to the power k plus 2. And then 2 multiplied by 3 to the power negative 2 plus 2 plus 2 multiplied by 3 to the power negative 1 plus 2 plus 2 multiplied by 3 to the power 0 plus 2 plus 2 multiplied by 3 to the power 1 plus 2. This we did it, it gave us 2. We did this, it was 6 plus 54. Is it 18? No, plus 18 plus 18 plus 54. Right? And then r is equal to t2 over t1, which is 6 over 2, which is 3. Again, r is equal to t3 over t2, which is equal to 18 over 6, which means r is equal to 3. Then we know what is r now, and we know what is a. R is 3, a is 2, right? Then we can use this formula, Sn is equal to a r to the power n minus 1 close bracket divided by r minus 1, right? Substituting, this is 59048 is equal to a is 2 into r is 3 to the power n minus 1 close bracket divided by r is 3 minus 1. And then this will be 59048 multiplied by 2, which is 3 minus 1. I cross multiplied here. And then we have 2 into 3 to the power n minus 1. Then divide by 2. Divide by 2. That 2 and 2 will go out. I have 59048 is equals to 3 to the power n minus 1. This to the other side, it will be 59048 plus 1 is equals to 3 to the power n. See, 59048 plus 1, it will be 59049 is equals to 3 to the power n. Let's see if it can be written in terms of factors. Yes, it's 3 to the power 10 is equals to 3 to the power n. Then 3 and 3 are bases and they are the same. Then we have n is equals to 10. N is equals to 10. We can substitute it here now. We can substitute it there. N, our formula says n is equals to x plus 3. But n is 10. This is equals to x plus 3. This to the other side, 10 minus 3 is equals to x. Therefore, the value of x is equals to 7. Right? That is the end of today's session. Don't forget to like, subscribe, and share the content with your friends. See you in the next video. Danko means thank you. Danko!